We would like to set up a microscope for standard bright field imaging. The first thing we need to decide is what microscope objective are we going to use in a particular experiment. Here are two objectives made by Zeiss. They are shown in the orientation in which they would be used in an inverted microscope. Before taking a closer look at the markings on the objectives, let's compare their overall physical appearance. The blue line shows that the lower edges of the silver casings of the two lenses are at the same level in this picture. In the microscope, these edges will sit at the exact same height when we switch between objectives by rotating the nose piece. On the other hand, we see that the objective tops are at different heights. Imagine that we place our specimen holder so that its underside coincides with the upper blue line. Then the distance by which we could raise each objective before it bumps into this holder is obviously different. So this illustrates the different working distances of the two objectives. A closer look at the threads at the bottom of the objectives exposes another physical difference. The thread on the right is much wider than the one on the left. This difference shows that these two objectives belong to different generations of microscopes that were manufactured at different times. In general, each objective is available with both versions of these threads. Which one you need simply depends on how old your microscope is. Zeiss does sell a step-up adapter that allows you to use objectives with the smaller thread on microscopes that normally expect the wider thread. The technical names of the two thread types of Zeiss objectives are RMS and M27, where RMS stands for Royal Microscopy Society. All major microscope manufacturers have switched from narrower to wider threads at some point, but it's important to note that the thread types used by different manufacturers may not be compatible. Now let's look at the objective markings. I'm adding another picture of the objective on the left so everything can be read clearly. Let's also turn this picture by 180 degrees so the orientation of the objectives is the same as it would be in an upright microscope. In addition to the names or types of the objectives, we see four different quantities. They are the magnifying power or magnification, the numerical aperture or NA, the tube length, which here is infinity. This means that both objectives are infinity corrected. Older objectives may have a number like 160 or 210 here. Such objectives are not compatible with infinity corrected microscopes. The final number denotes the thickness of the glass plate between objective and specimen that the objective is optimally corrected for. The units of this number are millimeters. For example, the number 0.17 means that the objective is designed to work best with glass cover slips that have a thickness of 0.17 millimeters or 170 microns. When you look at boxes of cover slips, the thickness is usually given in numbers like 1, 1.5, and so on. Number 1.5 cover slips have a thickness of 170 microns, the thickness that most objectives are optimized for. If no correction value is given on the objective, then this objective is not corrected for any particular thickness. There also are some long working distance objectives that have a correction collar. This collar then allows you to adjust the objective for optimal use with different glass plate thicknesses. Finally, one of the two objectives also indicates the immersion medium that it is used with. Air objectives usually do not show this, but oil immersion and water immersion objectives do.